Hello! Sorry, the webcam's a little low this week, but my name is Michael Whaling, and we are going to be doing another science experiment today. So today we will be cleaning pennies. I have some pennies from when I was younger that my mom had collected with my father, and these pennies are, these coins in the coin jar I have known since I was a tiny child myself, so cleaning them might be a pretty fun experience. First of all, just explaining the whole situation, we are getting pennies, mixing them with a solution that is salt and water, stopping whatever concentration happens with a normal water, and then drying them right here. So first, let's make our solution. We're going to get the salt right here. And then we're going to mix it together. Until there is no more salt in the solution. That's a pretty big salt crystal. I think if we do it like this, it will be less. That's a little better. Oh, man, I already started the recording, but I forgot the vinegar. I will be right back. Alright, coming back to it, I now have the vinegar, and I'm going to add it to my solution. So, before I add it, it is noted that if I mix water, salt, and vinegar, that it does create a compound called hydrochloric acid. I am in a well-ventilated room. I'm completely safe, but we're only going to add a tiny little bit here. Alrighty. Then we're going to mix that together. Man, I gotta say, I have never used more vinegar in my life until utilizing this class. It's very, I hate the smell of it. But anyways, we're going to see how dirty these pennies are. I'm going to get a little close up on these pennies right here. These are old. These are some old pennies. You can see they're very dirty. And these are the dirtiest ones that I found. So we will put those in. We'll put the bad boys in first, and we're gonna see how it goes. All right. Just gonna wait a little bit. Let's see how these guys clean themselves. I'm getting back to while I'm doing it. So, when looking at the formula here, you can pause the video if you'd like to look at the formula. Let's wait till it focuses. Here's the formula too. So we have 2 CH3 COOH, which is vinegar, salt, which is NaCl, copper, which is Cu. However, CuO is copper that's oxidized. We can see that when rust is formed, it forms CuO, making it oxygenated copper, causing the rust. So we're going to have a fluorine formula of 2 CH3COOH, plus 2 NaCl plus CuO, forward reaction to Cu, C2, H3O2, 2 plus 2 HCl plus Na2O. Again, here's the formula one more time. And this is going to be what is happening while we are adding all these substances together. Oh my gosh. Even from the little bit that I stepped away, it's like much cleaner. This is actually like really fascinating. It's they're all shining now. That is crazy. Let's give it a little more time. I want to see what happens. This is so cool. Wow. Those like 20-year-old coins are actually cleaning themselves right now. They're so much shinier than before. We'll just let it do its thing. We would have to add these pennies to a normal container of water to stop the reaction from happening. This is important because if you just leave the pennies out, it's going to form a greenish kind of tint on the top of it because we never stop the reaction. So it's actually going to speed up or going to keep going with the reaction in an oxygenated environment. And it's pretty cool. Like, honestly, like, I was pretty happy about it. But so based on this reaction, we are going to have a dissociative effect in the end product, and this is why the rest is removed. We are going to see the displacement reaction. So in the end product, we are going to see CuO, copper oxide, is split. The oxygen is now going to bind with sodium, and the copper is going to bind with the copper with the newly formed acetate ion, which is the C2H3O2. We are also going to have a new compound to form, which is HCl, which is the hydrochloric acid, which what we are using to clean the pennies. The process that it displays this displacement reaction will be successful in splitting the copper and the oxide, is leaving us with just the copper. Also in the end product, our solution becomes more acidic because we started with vinegar, which is a strong acid. We add salt to the reaction, which creates hydrochloric acid, which is a strong acid. Although, and this acid is found in our stomach, and as it's doing, it's corrosive, so it gets the rust off. And because of this reaction, the acid is going to break down into the end product, which is going to be a shiny, pretty penny. So that's actually really cool. They are much brighter now. I'm very fascinated by this. So we're going to kind of fish them out, and we're going to put them in the water to stop the reaction with the hydrochloric acid. It's like a carnival game. I feel like I'm playing right now. I got a little bit spilled right there. No problem, right? No problem. I kind of wish I kept a close eye of where that really old penny was to see how it would change after. So we're going to stop the reaction, let it sit there. I wonder if I use the spoon, actually, if it still has the hydrochloric acid on it, and I put it in the water, if that'll actually ruin the reaction. But it takes about 30 minutes to see the actual end results of it actually happening. But we're going to, again, switch these around. Oh, great. I'm dumb. I just spilled so much. That's why we have this work area, though. Little bloopers in the science lab. Good thing we're only working with salt, water, and vinegar. Alrighty. So let's get this right here. Let's put them onto our paper towel. Oh wow! I guess I should have waited a little bit longer. Because the really old ones, I'll show you right here. Let me take these bad boys out. Oh my gosh. It's kind of hard to fish these guys out. Let me dry what I have right now. I'm going to dry these, and I'll show you. This is so cool. This is actually very fascinating. Look. If you look here, this one is heavily cleaned. I should have left it in for a little. Oh, come on, let me get a good light on that. Look, so you can see spots of it are clean, but it was really, really getting at the core of this thing. That is so cool. Some spots still haven't cleaned up yet. Yeah, this side with the Lincoln on it, you can really see. Look at that. The whole thing's almost a different penny. You can see the old penny. You can see the old penny on the edges, right around his chin area. But then him himself is looking spick and span. That's so cool. Well, thank you for joining today, and I hope you have a great rest of your evening.